don't think that AI is replacing your job. It's actually giving you an opportunity to think more about what you're doing, right? The thinking, the design, the architectures, all of those things are things that we will continue to have to do, right? You're not, I mean, all right, maybe one day AI will develop an entire system from scratch and know exactly what to do, right? But that's not the case today, and I don't think it's going to be the case for the foreseeable future. You still need humans to define the problem, define the high-level architecture, understand the designs, and really, it's not thinking for you anymore. It's just doing the drudge work, right? And allowing you to get out of the weeds and see the bigger picture.
Hello and welcome everyone to our latest Agile Boston Podcast. My name is Joe DeAngelis, and I am very excited to introduce to you Mr. Dave Rubin, who is a colleague of mine at Microsoft and before that Nuance for several years. Dave comes to us as an architect, a really smart architect, engineer, and also a senior engineering leader. And today we're going to talk to Dave about his AI journey. And he's been, again, on the forefront of Microsoft's adoption of AI right from the beginning. So, Dave, welcome to the podcast. Thanks for accepting our invitation.
Thanks. Nice to see you.
So, Dave, talk to us a little bit about how it all started for you incorporating AI, because I know you're really knowledgeable about a legacy product, but you're also working on a new product also.
Yeah. So, I guess like everyone else, it started with chat, right? Learning about ChatGPT, what it can do, and kind of being amazed. And early on in the process, we started using ChatGPT for radiology report interpretation, right? And it was an old model back in 2023, but even back then, what it can do was pretty amazing. So we were actually using it right off the bat, building prototypes on reading radiology reports, extracting findings from those reports, and doing things that normally a human would take quite a bit of time to do. And we saw the power of it. Obviously, it was very raw back then, but I saw what it was able to do, and I knew right back then that the world was changing, and
it's only gotten better ever since.
Yeah, no, it's amazing what it can do right now. I've been playing with Opus 4.8 and Fable for a couple of minutes before they took it away, it's just this gets better and better and better, and the core intelligence of the models is just. I call it intelligence. It's not really intelligent. We have to remember that it's probabilistic, but it still is pretty amazing what it can do, and it's just going to keep getting better. And I think that it's here to stay. I think there is a lot of skeptics out there, and it's right to be skeptical. And in fact, the skepticism really helps, because when you're skeptical, you challenge it, you force it to prove itself, and you really need that in order for AI to be a successful tool.
Yeah, tell me a little bit more about that, because you're like around the same age as me. You're an old school developer. You've had your share of frustrating nights trying to figure out where your dangling pointers are and so forth. But how has that really changed the way you look at writing code or developing software now?
Yeah, no, I think a lot of developers are scared, right? Now they don't really have to write the code anymore, right? And that is good, right? People see it as existential, right? It's my job's going away. I see it as liberating. It is taking a burden off of our shoulders. We don't have to write C++ code anymore. We don't have to worry about pointers and memory and injection attacks and those kind of things in our code, right? We don't have to spend hours with a debugger stepping through and finding out why this variable isn't set. So while I think a lot of developers enjoy that, I think that from my perspective, I enjoy the higher level thinking a lot more. Architecture, design, planning, and understanding what we're building and how we're building it. And there's a lot of drudge work in engineering, and it's going away. So I think those who embrace that will find it liberating, because what it's doing is it's allowing us to spend the time that we normally spend in the debugger on higher level thinking. And it's important because the AI is not going to think for you. It doesn't know your domain, doesn't know the problem you're trying to solve, doesn't know your legacy code bases. And so you have to explain all of that to the AI. And in doing that, it forces you to think differently about the problem and maybe to be more formal about things that you weren't before, where I'm writing the code, so I don't need to worry about documenting all this design, right? Now you do, because if you don't, you're going to get in trouble, right? I mean, it was time to get on board. So the ones who get in trouble with AI are the ones who give it a vague statement and say, go off and write this or go off and debug this. And then it produces crap. And then like, well, AI is crap because they're not understanding AI, right? You wouldn't hire a software engineer or an intern, right? Even if he's the most brilliant guy in the world, he's from MIT, he's got a 4.0 GPA and he's brilliant. You wouldn't like give him a Jira ticket and say, go write code, right? You need to provide the context. You need to have him understand what you're building. You need to describe your legacy code base, your challenges, the domain of the product, right? And in my case, it's radiology. I mean, right now I can leverage my expertise in radiology and teach AI about radiology, right? Which is, you have to, because otherwise I won't know what to build. So I just think that there's a lot of skepticism and it's healthy, but I also think that what it does for engineers is it gives them the ability to think at a higher level and to really do things that maybe you haven't done all that well, right? Like I said, architectures, designs, and all that, with deadlines out there constantly. I mean, working at a big software company, it's like, we got to have a demo in 3 months. Sometimes you just cut corners, right? And you write code that's buggy and you don't really fully understand it. And I just think that those days are gone. You can't write code anymore without fully explaining it and understanding it, because if you don't understand it, the AI won't understand it. So,
you said something very, very interesting there, because it's not just saying to the AI, here's some context and here are the problems with the current code I have, and here's an architecture I'd like to build. But you said something very interesting. You have to teach the AI about radiology. And that goes beyond architecture. That's just the human side of things. Like, what do radiologists do? What do they value? And so forth. Is that correct?
yeah, absolutely. I think the domain expertise that you have in the problems that you're trying to solve is something that AI doesn't know. And so you have to teach it. You have to train it on those things. And the more that it understands about your knowledge, the more it's going to be able to produce a quality result. And it forces you to reframe your own thinking and to formalize it in a way that AI can understand. So I think it kind of reawakens some processes in our own brains that maybe we started to bypass because of real world pressures and the need to get software done quickly. And I think certainly at Microsoft and Nuance, there's plenty of buggy releases that have gone out the door. And maybe that wouldn't have happened if we were to take a step back and say, you know what, we're going to take an extra month here. We're going to document this design a little better. We're going to fully understand the problem we're trying to solve for the radiologist before we jump into a solution. And AI forces you to do that because it won't produce quality result unless you do. So I personally think it's liberating. It gives us the ability to think at a higher level and to let the AI do the drudge work. And I don't have to worry about pointers anymore. I think that's great. I think I'd rather explain context, and the goals and the story, and then have AI challenge me too, right? That's a big part of it. Is like, do you understand? And what don't you understand? And what did I get wrong? Tell me where I'm wrong. And so you have a healthy kind of debate with the AI to try and formalize what it is you're trying to ask it to build. So I think the people who are skeptical are obviously they're just going in there and just saying write code or fix this or do that. And sure, you're going to get bad results, but if you treat it like a colleague and not as a kind of a a machine that just knows how to write code, right? It's a colleague. It forces you to plan, and that's SDLC, right? I mean, it doesn't change the process. It just makes it even more important to use a sound SDLC process. So it's just accelerating what you already know how to do. It's not telling you I'm going to do it in a whole different way.
Right. That's really a good point. I was mentioning to you earlier that on a project I did recently, it was the best pair programming experience I ever had, because that's what it was. It was me and the AI talking about how to do something and what was the best way to do something, and trying different things. And like you said, it accelerates that whole process in getting to the right answer. So you're in a very unique position because you're an architect of a very old solution, decades old solution that is still very, very strong in the diagnostic space and heavily used. But you're also in a position where you're writing new product as well. And can you tell us a little bit about the differences between how you work with AI in those two instances?
Yeah, it's a great point. So obviously things are moving really fast in AI, especially in radiology. Just like developers, radiologists are supposedly going to all be replaced by AI too, right? That's not going to happen. But what will happen is that AI will help them get their jobs done faster. It will help them with the things, the drudge work on their side too, right? Where they're looking at an image and they're spending 4 hours trying to find a little nodule on that AI can find in a minute, right? So those kind of things are going to happen, but they have to be integrated with legacy code bases, because no matter what AI brings us, we can have all these agents running. But in the end, you've got your Epic EMR and you've got your PowerScribe system. You've got all these different pieces of the puzzle that are installed in your hospital that aren't going anywhere. And in fact, they can't go anywhere. They're providing the critical data. So you have to integrate with those code bases. And in order to do that, you've got to have APIs and other touch points. But the first thing you need to do is understand that code base. And I don't know about you, but when you have a 20-year-old code base, there's a lot of junk in there. And a lot of stuff that maybe you don't even understand anymore, or maybe other developers have put stuff in, and it's like it becomes spaghetti, a lot of it. And lots of code bases become spaghetti. It's just the nature of the business. So having AI analyze your existing code bases, it's kind of like a gift, because you can say, wow, finally someone can read this and understand it. Like, I don't understand what this guy wrote, but you can have it do that. And in fact, it's an important step. So I found, in trying to introduce new features into a legacy code base, the first thing you want to do is make sure that AI understands the code. And the way to do that is to use your own knowledge and experience in the code base to guide it to essentially analyze the code and say, a project I worked on recently, I was trying to figure out how to add a feature to a legacy code base. I said, first thing, I want you to write me a detailed design document on this part of the code. Right, here's this feature. Here's the user guide, so it knows what the user's doing in this product. Here's the actual code. Here's whatever design documents we did. And I got to admit, there aren't a lot. For some of that code, there aren't a lot of design documents. So, and you give it as much context as you can about what the application does and how it was built. And then you just say, go build me a detailed design. So don't ask it to write a feature. So build me a detailed design document about this particular feature. And then you challenge it, because it's not going to get it right. It's going to make a lot of mistakes. So then you go through it with the AI and you say, well, no, you got this wrong. Go back and check that method again. I think you got this wrong. Oh, good catch. It's always nice that it makes you feel good about yourself, right? Good catch. I found that. And you're, like you said, it's a pair programming exercise. And so now you've got the point where your AI is understanding the code base because you forced it to write a detailed design document. And now you could build off of that. You can say, okay, now that we've got this artifact, let's use that as a starting point. And it's amazing when you do that. It actually, when I did this in this code base recently, it found a defect. I didn't ask it to. It looked at the GitHub repo and the history, and it said, did you know that in November of 2023, there was a behavior change that was introduced in this feature? And sure enough, it was a defect, a 3-year-old defect that AI found that nobody knew. So
that's lucky. Lucky none of our customers saw it.
I know, I'm amazed. Maybe the customers did see it and they just didn't realize it was a defect. So these are the bonuses you get by, because it does do a very deep dive and it does find things and it finds connections that you may have missed. So in doing this exercise, you learn more, the AI learns more, and now you have context. So it's like, okay, now that you've created the detailed design document, tell me how I can implement this feature. Give me different choices. Let me choose the ones and ask me questions. This is so important, I think, with AI. You need to be a peer, a colleague. You need to tell it to challenge every assumption that it makes and to ask you questions along the way. So when I said, think really hard about this, meaning use your max model at max effort, which I don't play around with the other models. Give me a 4.8 model at max effort all the time, whatever the best out there is, and interview me, like whatever you don't understand, explain whatever. So you're in this interactive conversation, and in doing so, it's challenging you to think about things you didn't think about, and vice versa. So it becomes a rewarding experience. So you almost forget it's not a human that you're talking to, right? But as long as you work with it to build the building blocks or the foundations of what you're trying to get done, it will do a fantastic job. And then you break things down just like you would in any other SDLC. You don't let it write any code until everything's been planned. And the only thing it can do is it can work against a GitHub issue or an ADO story, whatever your process is. Mm-hmm. That's the lowest unit of work that you allow AI to do. It's only after you've distilled everything down, and now it's like, all I want you to do is work on this one story. It's going to probably get it right. If you ask it to work on the entire feature all at once, it's probably going to get it entirely wrong.
That's
So,
right.
and you don't know what the level of granularity is, right? Because you go too deep, you're just wasting your time. You go too high level, you're getting crap. So it's a learning experience for both the AI and the human to figure out what context do I need, how far do I need to go for you to understand things enough for you to write the quality code.
Yeah.
It's amazing if you get it right, and it's very rewarding.
You're absolutely right, and it can be frustrating too because I remember there was a day where I went back and forth with the AI all day, and we just couldn't get on the same page, and we just couldn't do it. And I went to bed, and I woke up the next morning, and I said maybe I should, get to that problem a different way. And I tried something different, and voila, it was a much better experience. So I don't know if you've had that experience where sometimes you're a whole day and you're like, I
Yeah,
can't tell me
yeah.
what
There's been some profanity in my AI conversations, and there are cases where I just tell it you're completely on the wrong track. Like, we're going to start a whole new session. Forget everything you've done. Go back to the original MD file. Let's
Yep.
start all over again. You have to do that sometimes because it will get off track. But that's just like like I said, any engineer that you hire fresh out of college, right? Brilliant guy, smart. He's eventually going to be probably one of your best developers, but he doesn't know anything. You just hired him, and there's going to be frustrations along the way.
Yeah, absolutely. And so that's working with a legacy code base. Anything different when you're working with new development?
Yeah, I think with new development, what we're finding is, and it's funny because you were always in a position of enforcing strict SDLC on us, and I would always be like, "Damn it, Joe, stop making us do all this." And now I'm realizing, like, no, with AI, it's even more important, right? To have that,
Absolutely.
and it can help you with the process, but you have to have that process in place, and you have to have a challenge response type of system where you never let it get away with anything without you being the approver, right? So, I mean, you're the human, and ultimately, you're accountable for this. So, AI is not going to be the one that gets blamed if something goes wrong. It's you. So, I mean, I think the real thing is that it removes you from having to debug those null reference exceptions, but it doesn't remove you from thinking and judging and designing and doing all the high level things that a software engineer has to do. You're just accelerating what you already do. So that SDLC is even more important. And the benefit of AI is that it can write all those things for you, right? It used to be, oh, I've got to spend a week writing a design document. Well, you can vibe a design document now with AI. You can just, well, let's write a detailed design for this feature. And then you iterate, and you don't have to write every paragraph. You can kind of iterate. And then, it might generate very verbose documentation, but then you can still use it because for the most part, AI is the one reading the documentation. And then you can, well, just give me an executive summary so that I can share with my leadership and those kind of things. You can always distill other documents from there. But to me, what it's doing is enforcing the need for a very strict SDLC. And that's especially true in healthcare, where we've got to have all sorts of compliance in place, SOC 2 and HIPAA and all those things. So you need to have all your decisions documented. You need to have a very strict process, and AI forces you to have that. And it's very helpful because you realize that, wow, if I had been doing this all along, my code would have had a higher quality. We just didn't have the time. Well, now you do.
It's interesting you said code quality because what do you say to the engineers that say, yeah, but Dave, AI writes really crappy code?
And it might, and I think, the problem is the ones who say it writes crappy code probably haven't given it enough instruction, right? They probably just said, go off and fix this bug for me, or go off and write this module. And they haven't given it enough instructions. And I do think that in general, when you're in the loop, it forces the AI to write good code. The other thing is it going to write the most readable, the human readable code? Probably not. I mean, even if you follow all the rules and you have strict SDLC and you narrow it down, you're probably going to look at its code and say, this is ugly. This isn't the way I would have done it.
Yeah, right. That's it. Any code that you didn't write is ugly code.
Usually most developers, if you're a good one, and you come in the next morning, and you probably would have done it differently from the
Yep.
And I remember when I was in the thick of just writing, I mean, every day I would wake up and I'm like, this is crap that I did yesterday. I'm going to do the whole thing. So it's just a natural instinct to always want to improve what you've done. And yes, AI is going to write some code that maybe is not the most elegant or even not the most human readable. But if you document it down to a very granular level, it doesn't really matter. And I think people will start to understand that. I'm a big fan. I always treat code as art. I've always made sure, all my spacing is correct and my variable names use the right casing structure. I've got my comments. And so I've always treated code as art. So it is a little bit difficult when I look at AI generated code and it's kind of messy, but I have to get over it.
Because like you said, right, as long as AI can read it and understand that that's what matters.
Yeah,
We're at a higher level now.
You don't have to understand every method, every single variable anymore, but you do have to understand the plan, and the testing is critical. So I think this is one piece. Any developer who's starting with AI, testable code is the only code, in my opinion. I mean, you can't, if your code doesn't have unit tests, component level testing, there's no point in writing it, right? Because in this day and age, the quality has to be the bar. And so with AI-driven development, and you could do true TDD, right? Test-driven development. You write your acceptance criteria in the stories. You write your tests first, and then you code to those tests, right? That I think is critical. I don't know that a lot of people are getting it that way, because if you don't write the tests first, what AI will do is it will write the code and then it will write the tests, and they will 100% pass because it knows I'm going to write.
It knows exactly what it's testing,
right? So if you write the tests first, then they say you cannot write a line of code until you write the tests, and then your code has to pass these tests. And those tests have to come from the acceptance criteria that maybe a software engineer didn't write, maybe a product manager wrote them. So you have to follow a TDD process. It's even more important than ever with AI, because otherwise, like you said, if you just let it loose and you give it no guardrails, it will write crap. There's no question.
Absolutely. As you've seen AI evolve, just give me like your number one takeaway that the audience here could really take home.
Yeah, I mean, I think, the main thing is that don't think that AI is replacing your job. It's actually giving you an opportunity to think more about what you're doing, right? The thinking, the design, the architectures, all of those things are things that we will continue to have to do, right? You're not, I mean, all right, maybe one day AI will develop an entire system from scratch and know exactly what to do, right? But that's not the case today, and I don't think it's going to be the case for the foreseeable future. You still need humans to define the problem, define the high-level architecture, understand the designs, and really, it's not thinking for you anymore. It's just doing the drudge work, right? And allowing you to get out of the weeds and see the bigger picture. And to me, that's a huge benefit, because every engineer is going to start using their intelligence more for the higher level thinking and less for the lower level debugging and code writing. And maybe it won't be as fun. I mean, look, I enjoy writing code. There's no question that part of me is like, oh, it's kind of sad I don't have to write this whole React module anymore. But I got over that really quickly. And be skeptical. Be skeptical. There's every developer tells me, hey, it's crap. I'm like, great. I love that attitude, because that's what you need. You need to challenge it. You need to say you're writing crap and find a way to tell to not write crap. So that skepticism is healthy, and in fact, it fuels. And AI wants that, because it wants to be skeptical. It wants you to push back on it, that's the way to be thinking. So you want to be skeptical, but you don't want to say I'm not using it because it's crap, right? The world has changed. Software engineering will never be the same. I believe very soon that developers won't be writing any code anymore manually. So you embrace it or you don't. If you don't embrace it, if you're not the type of engineer who wants to get out of the weeds and think at a high level, then you may have to switch careers.
Yeah, for sure. For sure. Well, Dave, thank you very much. This has been a wonderful conversation, and everyone, if you love this video, please hit that like button, subscribe to our YouTube channel, and you'll get a ton more content about this whole AI evolution and how it's really coming into our workflow and how we can best adopt it. So with that, thanks everyone. Thank you again, Dave, and we'll see you next time.
Thank you.